Hello everyone. In this session, we will see the concepts related to a graph. Up to last session, we have discussed various points related to the tree, general tree as well as binary tree. Okay, there are some more points related to this particular tree topic. We will discuss this as and when we proceed in our discussion. So now we will see a graph. So there is a difference between a tree and graph. We have to understand the difference first. What is the difference in a tree and graph? For a tree, if you draw any tree, so tree will be in this fashion. We are having a different nodes and they are connected. But if you observe this particular diagram very closely, then you can get the difference is that okay, this particular tree does not have any cycle, right? It means that you can go from A to B, or you can go from A to C, or you can go from B to C also. But to go from B to C, that we have to take the help of node A. Okay, so in this way you can go. But there is no cycle which is present in a given tree. So if you add particular age, okay, this particular age in given a tree, then the tree will convert it to a graph. The tree will be converted to a graph. So graph will have a cycle, right? So this is the cycle which is present in this particular graph. This is the cycle. You can go in any direction, in a clockwise direction, or you can go in anti-clockwise direction. It doesn't matter, but important thing is that in a given representation or in a given diagram, you are having a cycle, and this cycle indicates you are using a graph, you are not using a tree. Then if you consider any graph, then for any graph there are two types of graphs available. The one is called as undirected graph. One is called as a undirected graph, and the second is called as a directed graph. Okay, second one is a directed graph. So you can note down these two types, undirected graphs and directed graphs. Now we will see the difference between undirected graph and directed graph. We will see first what is undirected graph. So I am taking three nodes, node A, node B and node C, and these are the edges which is present in this particular representation. So but if you observe these edges, okay, if you closely observe these edges, then there is no direction which is given for these edges. It means that you can go from A to B, A to C, or you can go from C to A. Okay, it does not have any directions. Similarly, you can go from B to C, or you can go from C to B. There is no directions available. Similarly, you can go from A to B, or you can go from B to A. There are no directions available. So if such type of representation is there, then it is called as an undirected graph. The graph which does not have any direction given on these edges, it is called as an undirected graph. Okay, I repeat the definition. The graph in which there does not exist any direction, okay, on given edges of a graph is called as an undirected graph. And exactly opposite of this particular definition, it is called as a directed graph. Directed graph means you have taken one example. Okay, you have taken one example, okay, for a graph. Okay, and now you are giving a directions here. You are using some directions. Okay, so this particular representation has directions. So from node A, you can go to node B. From node A, you can go to node B. It is possible. But from node B to node A, there is no path exist. You cannot go from node B to node A directly. Similarly, from node C to node B, you can go. It is possible because edge is present. Directional edge is present. From node C to node A, you can go because directional edges is present. But from node A, you cannot directly go to node C. So such type of representation is called as a directed graph representation. Okay, there are different applications in which we are using undirected graph. There are some other applications in which we are using a directed graph. Okay, it depends upon the application, it depends upon the system you are developing. Okay, in some systems we require undirected graphs, for some systems we require a directed graph. It is up to the situation in which you are working, right? So that is not our point of discussion. Now important thing is that generally we are using a undirected graph only, generally. Okay, there are some application in which we are using a directed graph. So when we are using some greedy algorithms, we are using some shortest path algorithm. In such cases we are generally using a directed graphs. Okay, otherwise we are using a undirected graph only. So now as per our curriculum also we are having a undirected graphs, or our focus is on a undirected graph only. So we will take one example, or we will try to solve one example. Okay, so in summer 18 question paper, in a question number 5b, we are having one question. The question is that, you can write down the question. Okay, I am telling you the question. Consider the graph given in the following figure. Consider the graph given in the following figure and answer given questions. Answer given questions. And they have given a graph. Okay, considering that graph only, we have to answer the different questions based on that graph. And the graph which is given is in this question, typically it is a directed graph. Okay, so they have given this directed graph. So it is possible that in your question paper they may give a undirected graph also. Okay, but in last question paper they have used a directed graph. Okay, so the graph contains these nodes. Node 1, okay, they are numbered node only. Node 4 and node 5. So graph contains 5 nodes, and there are directed, it is a directed graph, so it has a directional edges. This is the edge. I am drawing a edge only, but it is having a direction. It means that you can go from node A, so that is node 1 to node 2. Similarly, there is a directional edge. You can go from node 3 to node 2, from node 1 to node 3, from node 3 to node 4, from node 5 to node 3. So this is your given graph. They have given this graph for a question. Okay, and they are asking some questions or small questions based on this graph representation. I think you have drawn this particular graph representation. Now we will try to solve the questions one by one. And the first question is you have to write down all simple path from, write down the question, all simple path from 1 to 5. It means that from node 1 to node 5 you have to write down all simple paths. Okay, the paths or the simple paths which are available from node 1 to node 5, you have to write down it. The question is little bit tricky, but if you understand the principle, it is very easy. Okay, now you can focus on given diagram. You have noted down the diagram, right, in your notebook. Okay, now you can focus on the given diagram. If you observe this diagram very closely, then you can identify from node 1 you can go to node 2. Right, from node 2 you can go to node 5 because the edges are present. Okay, so from node 1 you are going to node 2, from node 2 you are going to node 5. So this is nothing but a path from node 1 to node 5. You can take good example. Okay, you want to go from Malwan to Kankoli. Let us consider. Okay, then you are going from Malwan to Kasal, and then you are going from Kasal to Kankoli. So this is nothing but you are going from node 1, that is a Malwan, to node 2, that is Kasal, and from node 2 you are going to node 5, that is Kankoli. So there is a path, simple path is available. You can follow the path, you can reach from Malwan to Kankoli, or you can reach from node 1 to node 5. It is very easy. This is nothing but a simple graph. This is nothing but a simple path. Okay, so the first simple path is node 1 to node 2, from node 2 to node 5. Now, you can observe the diagram closely again and try to find out some more paths are available or not. Okay, from node 1 you can identify, from node 1 you can also go to node 3. From node 3 you can go to node 2. From node 2 again you can go to node 5. So this is nothing but a simple path. which is also again available, right? So from node 1 you can go to node 3, from node 3 you can go to node 2, from node 2 you can go to node 5. Okay, so for this I will give one more example. You want to grow from Malvan to Kankoli, so you are going from Malvan to Kudal, from Kudal to Kasal, and from Kasal to Kankoli. Okay, so you are going from Malvan to Kudal. Okay, from Kudal you are going to Kasal, and from Kasal you are going to Kankoli. Okay, so in this case it is possible. Okay, so you may say that this is a longer route, okay, or it is having a longer path. Okay, but we are not looking, okay, whether it is a longer route or shorter route, whether it is a shortest path or longest path. We are not looking into that particular part. Okay, in a data structure there is a concept called as the shortest path or longest path. Okay, there are algorithms based on this shortest path or as well as longest path also, but this is not part of our discussion. We just want to identify the paths. We just want to identify the ways which are available to go from one location to another location, to go from source to destination. So the path exists, you can write down the path directly. So the first simple path is from node 1 to node 2 to node 5, and the second simple path is from node 1 to node 3, from node 3 to node 2, and from node 2 to node 5. Okay, so this is the first bit we have completed. So this is very easy. Okay, if you use your technique, if you follow the principle, then it is very easy. Now we will go to a second question or second sub-bit. There are actually 4 sub-bits which is available in this question. And the second sub-bit is in degree and out degree of node 4. You want to write down in degree and out degree, in degree and out degree of 4. So we go one by one. Okay, we have seen what is in degree and what is out degree in some previous sessions. If you haven't gone through my previous sessions, you can visit my YouTube channel. You are getting these things. I have already explained about in degree. Okay, so now you can identify node 4 first. For a node 4, okay, there is one incoming edge. There is one edge which is coming to node 4. Okay, so if you want to write a in degree of 4 or in degree of node 4 means you have to identify number of edges which are incoming to node 4. Number of edges incoming to node 4. तर node 4 कडे येणाऱ्या edges बघायचे आहेत आपल्याला. For a node 4 there is only one edge which is incoming to node 4. Right? There is only one edge. Then in degree of node 4 is 1. In degree is 1. Similarly, if you observe for a node 4, there are no outgoing edges from node 4. Node 4 कडून बाहेर जाणाऱ्या कोणत्या edges available नाही. There are no outgoing edges or coming out or edges coming out from a node 4. In that case, out degree of node 4 is 0. Out degree is 0. So in this way you can write down what is the in degree or out degree of any node. If you consider node 3, okay, this is not asked in this question, but if they have asked, they might ask, okay, for a node 3 write down in degree. Then for a node 3, okay, there are only one edge incoming to node 3. Okay, actually there are 2 edges incoming to node 3. Then for a node 3 in degree is 2. Okay, similarly for a node 3 there are 2 edges which are going out from a node 3. It means that out degree of node 3 is 2. If you take any example, if you take node 2 also, for a node 2 there are 2 edges incoming to node 2, then in degree of node 2 is 2. But for a node 2 there is only one edge outgoing from a node 2, then out degree of a node 2 is 1. In the same fashion you can answer for any node, you can easily answer what is the in degree of a node, what is out degree of a node. Okay, so here we have completed the second bit of this question. The next part is you have to write down, that is the question is give adjacency matrix. Write down this question clearly. This is a new thing you are understanding. Right? Give adjacency matrix for given graph. So graph is already given to you. You want to write the adjacency matrix for given graph. Okay. So what is adjacency matrix? Okay, you know about a matrix. You have studied what is matrix in your mathematics classes, right? So now we have to understand what is adjacency matrix. So adjacent means neighboring. Okay, adjacency matrix means the matrix in which we are identifying or we are showing neighboring nodes. Neighboring nodes or adjacent nodes, it is called as the adjacency matrix. So if you take any node in a given graph, if you take node 1 in a given graph, then you have to identify which nodes are the adjacent node for node A1. Okay, and you can represent it. Similarly for a node 3, okay, you can identify adjacent nodes for a node 3 and you can represent it. Okay, when you represent in a matrix format, that is called as the adjacency matrix for a given node. And if you represent it for all nodes in a given graph, that is adjacency matrix of given graph. Now I will tell you how to represent it. Okay, this is very easy how to represent the adjacency matrix, right? So I will call that adjacency matrix as A, capital A. Okay, so this is a matrix representation. So I am using this matrix representation format. On the left hand side, I am writing the numbers. So these are the node numbers. In given graph, there are 5 nodes. So 1 to 5. So actually there are 5 rows. Similarly, there are 5 columns. 1, 2, 3, 4 and 5. Because the graph consists of 5 nodes, it means that it is a 5 by 5 matrix representation. If graph consists of 10 nodes, then it is a 10 by 10 representation and so on. Okay, so number of nodes which is present in a graph is nothing but number of rows in a given matrix. Similarly, number of columns in a given matrix is nothing but number of nodes in a given graph. So it is a symmetric matrix representation. You can easily identify it, right? So now we go one by one. Okay, we follow the diagram or we follow the graph only. Okay, if you observe node 1, okay, for a node 1 you cannot grow. Okay, from a node 1 you cannot go to node 1 again. त्याच नोडकडे आपल्याला येता येत नाही, सेल्फ लूपिंग नाही आहे. मग फ्रॉम नोड 1 टू नोड 1 देर इज नॉट एक्झिस्ट एनी एज. नोड 1 कडून नोड 1 कडे परत येता येत नाही. ओके, मग एज अवेलेबल नाही, मग तिथे काय लिहायचं, 0 लिहायचं. ठीक आहे. फ्रॉम नोड 1 टू नोड 2, ओके, देर एक्झिस्ट एन एज फ्रॉम नोड 1 टू नोड 2. ओके, सो डायरेक्शन एज एक्झिस्ट, देन यू कॅन राईट डाऊन 1. ज्या ठिकाणी एज एक्झिस्ट आहे, डायरेक्टेड एज एक्झिस्ट आहे, त्या ठिकाणी आपण 1 लिहिणार आहोत. ज्या ठिकाणी एज एक्झिस्ट असणार नाही त्या ठिकाणी आपण 0 लिहिणार आहोत. एवढं सोपं आहे. फ्रॉम नोड 1 टू नोड 3 directional edge exists, so you have to write down 1. From node 1 to node 4 there does not exist any edge, so you have to write down 0. You have to write down 0. From node 1 to node 5 there does not exist any edge, you have to write down 0, right? Okay, similarly you can go for a node 2. For a node 2, okay, you cannot go from node 2 to node 1. Okay, edge exists from node 1 to node 2, but edge does not exist from node 2 to node 1. It is a directional edge. नोड 1 कडून नोड 2 कडे जाता येतं, पण नोड 2 कडून नोड 1 कडे जाता येत नाही. खूप महत्त्वाचं आहे, मगाशी मी सांगितलं आहे. सो दॅट एज इज डज नॉट एक्झिस्ट. फ्रॉम नोड 2 टू नोड 1 यू कॅनॉट गो, सो व्हॅल्यू इज 0. फ्रॉम नोड 2 टू नोड 2, ओके, सेल्फ लूप डज नॉट एक्झिस्ट, ओके, व्हॅल्यू इज 0. From node to node 3, okay, edge does not exist. From node 2 to node 4, edge does not exist. Okay, from node 2 to node 5, edge exists. You have to write down 1. Similarly, you can follow for the remaining nodes. From node 3 to node 1, edge does not exist. 3 to 2, there is a edge. From 3 to 4, there is a edge. From 3 to 5 there does not any edge, right? Similarly for remaining nodes you can write down it. Okay, so this is the adjacency matrix representation for given graph. Okay, so in the next session we will see how to perform a adjacency list representation for a given graph. Okay, thank you for watching this session.